Assalamualaikum warahmatullahi wabarakatuh. Good morning, students. How are you today? Good. Well, before learning today, let's pray together. Pray begin. Finish. And don't forget for absent in the Google Classroom right now. Okay, I believe that have you been ready with your equipment, your handphone or network on your laptop that can support our online learning process today. Let's start study. And now we will study about the particulate nature of matter. To the lecture, you should be able to state the distinguishing properties of solid, liquid, and gas. Describe structure of solid, liquid, and gas in the term of particle separation, arrangement, and type of motion. Describe change of state in the term melting, boiling, evaporation, freezing, condensation, and sublimation. And last, explain change state in the term of kinetic theory. We have three different states of matter. What is that? Three different states of matter are solid, liquid, and gas. We will take a look at the distinguishing properties about them. First, solid. Solid have fixed shape and a volume. They will maintain their original shape and a volume, and will not flow even if they do not have a container around them. For liquid, they change easily and will take the shape of the container, which means their shape depends on the place they rest on. They will flow easily, unlike solid. For gas, have a very different properties compared to solid and liquid. They have no fixed volume and no fixed shape. They will not take the shape of the container, and it is impossible to keep them in a fixed position. Another thing to note is their mass. They are much lighter than a solid and liquid. Now, let's study the difference in the structure of solid, liquid, and gas. First, solid. Solid is always arranged as a lattice. This picture shows what a lattice looks like. They are able to stay in this position as there are strong forces between the particles. Furthermore, they do not move around but only vibrate in a fixed position. Next, liquid. A liquid not be lattice. The particles are close together but not in a lattice. But there are weaker forces between the particles, resulting in a low shape compared to a solid. This also allows the particle to can move about and slide past each other. And last, gas. Gas will again have a completely different property. Its particles are far apart, having almost no forces holding them together. They are free to move about very quickly, collide with each other, and bounce off in all directions. Change of state. All substances are allowed to change its state under different temperature. Starting from solid, it can be changed to liquid by a process called melting. Think of an ice under hot sun. You will see that it has turned water within a second. As long as temperature is higher than 0 degrees Celsius, it will immediately start to melt, and its temperature is called the melting point. And next, we'll see the melting point process.
Melting point of ice. We require ice cubes, beakers, thermometer, stirrer, a stand with a clamp, wire gauze, tripod stand and a Bunsen burner. Take some ice cubes in a beaker. Place the beaker on a wire gauze, keep it over a tripod stand and insert a stirrer into the beaker. Take a thermometer and suspend it with the help of a clamp stand so that its bulb remains in the middle of the ice cubes. Heat the ice cubes in a moderate temperature using a Bunsen burner and stir continuously to keep a uniform temperature throughout. Note the temperature T1 when the ice starts melting. Continue heating the ice. Note the temperature T2 when the ice is completely melted into water. The average of the two temperatures gives the melting point of ice. The melting point of ice is 0 degrees Celsius.
What if we want to change it back from a liquid to solid? We can simply freeze it back by lowering the temperature to below 0 degrees Celsius. Another name for this temperature is a water freezing point. Next, we will see the freezing point. A liquid can be changed to gas by increasing the temperature. In the case of water, if the temperature goes above 100 degrees Celsius, it will be changed to water vapor. This process is named as a boiling, and its temperature as the boiling point of water. And next are video of boiling point.
Boiling point of water. We require distilled water, boiling tube, beakers, thermometer, a spatula, pumice stone, a stand with a clamp, and a Bunsen burner. Take about 25 ml of distilled water in a boiling tube and clamp it to the stand. Take a few pumice stones using a spatula. Put them into the boiling tube containing distilled water to avoid bumping while boiling. Cork the boiling tube with a double-bored cork. Insert a thermometer through one bore of the cork. Keep the bulb of the thermometer about 3 to 5 centimeters from the surface of the water. Take a delivery tube and insert one end of the delivery tube through the second bore of the cork and insert the other end of the delivery tube into a beaker. Take a Bunsen burner and heat the boiling tube gently by rotating the flame. Note the temperature T1 when the boiling of water starts. On boiling, water is converted into steam which passes through the delivery tube, is condensed and gets collected in the beaker. Continue to heat the water till the temperature becomes constant and the water continues to boil. Note the constant temperature T2. The average of the two temperatures gives the boiling point of water. The boiling point of water is 100 degrees Celsius.
And it is also a process where a liquid changes to gas. And this is video of evaporation process.
For this experiment, you will need water, a marker, a clear cup or jar, and sunlight. Fill the cup 2/3 full of water. Mark the waterline with a permanent marker on the outside of the cup. Place the cup indoors or outdoors as long as it is in direct sunlight. Each day, mark the waterline. As the sun heats the waterline will decrease because it is evaporating. This process is known as evaporation. For this experiment, you will need hot water, 2 cups, and some ice cubes. First, boil a kettle full of water. Fill 2/3 of 1 cup with the hot water you just boiled. Flip the second cup, placing it upside down on the first cup. Balance an ice cube on top of the flipped cup. It is very slippery, so make sure it does not fall off. As the ice cube melts, condensation will begin to form inside the second cup. If you look very closely, you can see the smaller water droplets form together, making bigger water droplets. Clouds are made of these same water droplets, but in the sky. If you wait long enough, a big water droplet will form underneath the ice cube. This is because the ice cube, like the atmosphere, is cold, and the water underneath it, like the surface of the Earth, is warm. This process is known as condensation.
And last, a solid can be changed directly to gas by a sublimation. And this is a video of sublimation process. What we have covered so far sums up and explains the kinetic theory. Here's a list of points that defines kinetic theory. First, a substance can be solid, liquid, or gas and change from one state to another. For example, from liquid to solid. Second, it has different characteristics in each state. For example, is solid do not flow. The last, the differences are due to the way the particles are arranged and move in each state. For example, gas particles are far apart from one another. Well, the conclusion learning today is we study about the state distinguishing properties of solid, liquid, and gas, describe structure of solid, liquid, and gas in the term particle separation, arrangement, and type of motion, describe change states in the term melting, boiling, evaporizing, freezing, condensation, and sublimation, and the last, define of the kinetic theory. I think it's enough for today, and don't forget for collect the statement in the Google Classroom. Okay, good morning student. Assalamualaikum warahmatullahi wabarakatuh.